Okay, we're going to do 4.1 today, apply triangle sum properties. We're going to go back to our regular style of class. Hopefully you enjoyed the break from the videos, but we're now going back into the videos for a little bit. And so let's go ahead and just jump in and get started. We're going to talk about, again, triangle sum properties. We're going to talk about polygons. Those of you already probably know this, but a polygon is a closed figure with 3 or more segments for sides. Okay. Again, notice the word segments there. It's got to be a segment. You cannot have an arc closing the 2 segments. It's got to be 3 or more segments for sides, okay? So the most basic form of a polygon is your triangle. It's a 3-sided polygon. It's the smallest polygon you can have. One might actually say that it's one of the most important polygons only because it is, like I said, the smallest polygon that you can possibly have. And yes, I know it's hard to believe for some people out there that a triangle is actually a polygon. I'm not going to say who those people are, but in any case, we'll keep moving forward. We can classify triangles by their sides. Last unit we classified them by their angles. Now we're going to classify them by their sides. Some of you might already know this information. First, we have scalene, and in a scalene triangle, and you're going to need to know this for tomorrow when we do our little activity tomorrow. In our scalene triangle, we have 3 sides, none of which are equal to one another. If you look here, you can see that none of these have the same congruent markings, so it's 3 different sides. Isosceles has 2 of the same sides. Okay, the third side is obviously different. And then finally, an equilateral triangle has 3 sides that are all the same. And I want to make a quick point. If you're asking yourself, well, are equilateral triangles isosceles triangles? Absolutely. An equilateral triangle does meet the requirement of isosceles, so all equilateral triangles are isosceles. However, are all isosceles triangles equilateral? The answer obviously is no, because you only need 2. It's kind of like, and I don't know if I talked about it with you this year or not, but I know with my Algebra 1 students, I told them that it's like a square and a rectangle. The definition of a rectangle is 4-sided polygon with 2 parallel sides or 2 equal sides, and a square fits that. So a square is a rectangle, but not all rectangles are squares. So similar concept there. Okay, again, just kind of a review of classifying triangles by their angles. An acute triangle has 3 angles that are less than 90 degrees. Okay, so this would be your acute triangle. I'm sorry, yeah, 3 triangles that are less than 90 degrees. Notice that all 3 of these angles are equal to 180 degrees. So measure of angle 1 plus the measure of angle C plus the measure of angle A, excuse me, B plus C plus A equals 180 degrees. All triangles equal 180 degrees. We should already know that. That shouldn't be anything out of the ordinary. Okay. A right triangle has 2 angles that are acute, and then you have a 90-degree angle, that right angle. Okay, but notice that the measure of angle D and the measure of angle F is equal to 90 degrees. Well, that makes sense, right? Because 180 minus that 190 that's taken away already to make it a right triangle, that leaves only 90 more degrees to be separated by 2 angles. With that being said, using our common sense and making a conjecture, we can say that acute triangles, or I'm sorry, right triangles will always have acute angles. There's no such thing as an acute, there's no such thing as a right obtuse angle. Because since a triangle is only 180 degrees, if you have 90 degrees, you can't get higher than 90 in order to get 3 sides. Okay. Hopefully that made sense to you. Okay, and then of course we have an obtuse. That means we have an obtuse angle in that triangle. Okay, so in this case, angle H is 110.4 degrees. Okay, so you have your obtuse triangle. Okay, no matter what I do, you have one angle that is greater than 90 degrees. Okay. You also have what's called an equiangular triangle. Okay, that's where all the angles are the same. Okay, all the angles are the same. And what we're going to learn later is if all the angles are the same, that means all the sides are the same. So equiangular triangles, are also equilateral triangle. So in this case, in order for them to all be the same, they have to equal 60 degrees. Okay. So all angles are 60 degrees. Okay. Okay, so now that we've got our angles classified by sides, and our angles classified by angle, our triangles classified by sides, and our triangles classified by angles, now we're going to start looking at some different things with a triangle. Okay, so we've already discussed the fact that all triangles are equal to 180 degrees. Okay, excuse me. Okay, so here you have 51 and 40 makes 91. 91 plus 89 is your 180 degrees. Well, let's take a look here. Look how we've drawn this triangle. We've drawn this triangle with essentially 3 segments that overlap. Okay, and if you notice here, what is this angle L and this angle N? I'm sorry, this angle KLM and this angle KLN. What do these two angles equal? That's right, they're 180 because they're supplementary. They are a linear pair, so they create 180 degrees. Okay, obviously 51 and 129 are also another linear pair. They create 180 degrees. And then you have your 40 and 140 that also create 180 degrees. Now, with that being said, our whole triangle equals 180 degrees. So let's take a look at this. Let's take this out of the equation. Actually, let's do it this way because it's going to match our caption. Let's take the 89 out of the equation. Okay? What do these two angle measures equal? Okay? Well, 51 plus 40 is 91. Notice that's what that is. So you can say that the measure of angle M, this measure here, plus the measure of angle K, this measure here, equals 91 degrees. That's because measure of angle L here and the measure of angle N here, they're a supplementary, meaning they equal 180 degrees. And remember, the entire triangle equals 180 degrees. And so if I take this one out, this is my supplementary angle, okay? These two angles are going to match with this one. Likewise, if I take this 40 out, what is 89 plus 51? That's right, it's 140. Okay? So the measure of angle L plus the measure of angle M is equal to 140 degrees. If I take this 51 out, what does 89 plus 40 equal? That's right, 129. And I know you're probably sitting there going, well, yeah, I get it. Angle L plus angle K equals 129. But this is going somewhere, okay? What we've noticed is that all of these are 180. If you have a linear pair, that means these angles right here are called exterior angles. This angle here is an exterior angle. This angle here is exterior angle. This angle here is exterior. That exterior angle is going to equal the other two angles, okay? Just out of curiosity, what does the outside of the angles equal? What do all the exterior angles equal? 129 plus 140 plus 91. That's right, they're 360. So exterior angles equal up to 360, okay? That is always going to happen. If you draw a triangle like this and you have the linear pairs created, on the outside you're going to have 360. The exterior angles are going to equal 360. The interior angles, or the inside of the triangle, is going to equal 180. All right, let's take another look at this example down here. Let's take a look at this example on the bottom. Before we get started, what do you think angles 1 plus angles 2 equals? For angle 6. How about angles 2 and angle 3? What do they equal? Angle 5? How about angle 3 and angle 1? Right, they equal angle 4. Okay? So let's take a look. We know that measure of angle 1, 2, and 3, that's the inside of our triangle, that equals 180 degrees. Okay? We also know, because we just talked about it before right here, that we know the measure of angles 5, I'm sorry, let me go back one step. That's the triangle sum. And that's actually a theorem that tells you that 1, 2, and 3 are equal to 180 degrees, because that can be proven that it's 180 degrees, that all triangles equal 180 degrees. Okay? Let's look at this now. The measure of angle 2 and 4 are equal to what? 180 degrees. And why is that? It's because they are a linear pair, right? Now, I can take this 180 degrees and substitute it with 1, 2, and 3. So now I would have 1, 2, and 3 is equal to 2 and 4. What property did I use there? That's right, substitution. Okay? Now notice I have two angle measure 2's. I can cancel those out. And now I have the angle measure of 1 plus the angle measure of 3 equals the angle measure of 4. So 1 plus 3 equals 4. Didn't we say that before we started? And we use the subtraction property in order to take those 2's out. This is called the exterior angle theorem. We just proved the exterior angle theorem. And the exterior angle theorem states that an exterior angle is equal to the two remote interior angles. Okay? So 6 is the exterior angle, the two remote is 1 and 2. So 6 is equal to 1 and 2. What's the remote angles to 4? Well, we just did that one. That's 1 and 3, right? What's the remote angles to 5? That's 3 and 2. Remote means farther away, a distance, right? Not close, it's remote. It's kind of away, okay? Separated. So that is the exterior angle theorem. That'll help us solve some things. Okay, so now that we have the information, now that we know the exterior angles equal 360, we know the interior angles equal 180, we know that the exterior angles are equal to the remote interior angles, we know how to classify triangles by angles and by sides. Let's go ahead and do some examples. Okay? Well, all right, let's look at these real quick. And I just had the answers up there. Hopefully you didn't catch them and write them down real quick. Okay, so right here we have 2x, angle 2x, angle 3x, and 55. How would I solve for x? Well, because we know that our interior angles equal 180 degrees, we know that we have 2x plus 3x plus 55 equals 180 degrees. And we're not going to go through the algebraic process, but we know we can combine like terms. You get 5x plus 55 equals 180. Subtract 55 from both sides and divide both sides by 5. Okay, we know that. I know you can do the algebra. Let's look at this one here. How would I solve for x? Can you tell me what x is right now? That's right. If you said 120, you'd be right, because we use our remote angles here, because this is our exterior angle that's equal to our two remote angles. So exterior angle, 1, 2 remote angles, 50 plus 70 is 120, and so that equals x. So x equals 50 plus 70 degrees. Could also have done it the long way, which says that 50 plus 70 is 120. 120 minus 80 is 60. So this angle measures 60, so x plus 60 equals 180. We could have done it that way, but that's the long way. Who wants to do that? Okay, and then our last example, how would we solve for this x right here, these x's? Okay. We could set 103 minus x, that's the remote angle, plus another remote angle of 2x, okay, equals this exterior angle, 6x minus 7. And then you just solve for x, okay? And here's the process for that. Since it's a little lengthier, okay, you drop the parentheses, combine your like terms, get x on the same side, and then divide both sides by 5, and then you're good. And that's pretty much to it. That's pretty much all there is to it. There's not a whole lot more than that. There's your homework right there. There's more homework posted on Blackboard, or check the Blackboard for your homework, and then be ready to come in tomorrow. Have a great day and a great evening.